Problem number one, I'm still in electrostatics section. This one says a magnetization curve for the cast steel of an inductor core is shown on the right side. The magnetic flux in the steel is 8 times 10 to the power minus 5 Webers. So the question here is to find I. So we have the formula here, and I is equal to HL. So I is therefore equals to HL over N. So I always start with whatever I'm asked to find, and basically kind of find the formula for that and make sure I display what I know and what I don't know, the knowns and the unknowns. So I know N, I know L, but I don't know H. So how do I find H? Essentially, I'm going to go to the graph that's given. So we have a graph that's B in terms of H. So naturally, I have to find H from the graph. Alright, so I pretty much have a formula for B. So B is equal to, is it phi? I don't know if that's a phi or omega, but whatever that is, it's the magnetic flux over the area. Alright, so we're going to calculate B. B is the flux density, and that's in Weber per meter squared. So it's already given, phi is already given as 8 times 10 to the power 5, and area is 0.0004 meters squared. So I just replace it and calculate B. Over 0.0004. And so using the calculator, B is equal to 0.2 Webers per meter squared. Alright, so now I'm going to go to the graph and plug it in. And remember, here we are told that this is a cast steel. So I have a graph for cast iron, I have a graph, a line, maybe a curve or whatever for cast steel, and another one for whatever else it is, but I'm dealing with cast steel here, so I'm only worried about that. So if I project that 0.2 to find H, so H will be 200. Okay, so now we have everything that we need in order to find I, the current. So now all we need to do is just plug it back in, everything that we know, and calculate I. So this one is pretty much also straightforward. All we need to just do is lay out what we know and what we don't know and trying to find what we don't know. So I is equal to 200 times 0.2 over 50. 200 over 50, that's 4. 4 times 0.2 is 0.8. So the current is 0.8 amp. That's our final answer. Of course, multiple choice, we get the right answer from the multiple choice questions. Okay, problem number 2. Here we have, if the two charges are separated by air, what is the force between them? Okay, So what's my question? My question is, what's the force? So what's the formula for force? F is equal to Q1, Q2 over 4 pi E R squared. So what do I know? I know Q1 is given as 15 microcoulombs. Q2 is also given as 10 microcoulombs. Epsilon or E is that of air, so that's also known. If you look at the first page of the book, that's 8.85 times 10 to the power 12. What's the unit? It's F per meter. Alright, so R. Now R is the unknown here in this particular case. So how do I calculate R? From the graph that's given on the right, this is a triangle. So basically finding R is obvious also. Basic math, 0.25 squared plus 0.25 squared, square root of that. So that is this is 0.25 times square root of 2. Now I could have just put the answer in there, but I want the full number, so I'm just gonna put square root of 2, just to kind of have the exact answer that I'm looking for. So now from here, let's pretty much plug it in. So we have everything that we need as 15 times 10 to the power minus 6 times 10 to the power minus 6 over 4 pi times 8.85 times 10 to the power 12, replacing R squared, and we have 0.25 times square root of 2, everything squared. Now using a calculator, simple. My final answer for the force is 10.79 newtons. That's the final answer for that. That's it. Okay. Alright, another problem, the last problem for today, or for the night, or whatever. So this one says a thin metal plate with dimensions 20 centimeters by 20 centimeters carries a total charge of 24 microcoulombs. The question is, what is the magnitude of the electric field 2.5 centimeters away from the center of the plate? So what do I know? I know area is given as the 20 centimeters by 20 centimeters, so that's 0.2 squared. Of course, we have to convert that into meters because we want to deal with the international, whatever they call it. Just convert it to meters, convert everything to the standard. Alright, so Q is 24 microcoulombs. That's also known. And so the question here is, find the electric field, the magnitude of the electric field, E. So we have to use a formula, of course. Checking it out, which formulas I have to use, because I have the knowns, which are A and Q. And so the formula that I'm using is going to be E, which is the electric field, is equal to rho S over 2 epsilon. This is not in the book though. I found this in another book, in another source. So, but still, we should know this anyway from class, from all lectures, engineering classes. So, E is equal to rho S over 2E epsilon. So I do know E, and that's, this is small e though. That's 8.85 times 10 to the power 12. And so I don't know what rho S is. And that I'm going to have to get from the chart as given and the area. So naturally the formula is Q over A. So rho S is Q over A, just replacing the values. So Q is 24 times 10 to the power 6. Of course, we're going to convert that to coulombs over the area, which is 0.2 squared. And using calculator, this is 6 times 10 to the power 4 coulombs per meter squared. Okay, so I know everything now. All I'm going to do is just to go through the original formula to find the electric field, replacing by the values that I just calculated, since I know everything now. So I have rho S, which is 6 times 10 to the power minus 4 over 2e, and this is 2 times 8.85 times 10 to the power 12. And so the electric field, using calculator again, is 3.39 times 10 to the power 7 Newton per coulombs. So that's our final answer. And that's it for today. So next time I'm going to find other problems as well to solve.